So instead of using the table on this one, let's do it using the graphing method of graphing cosine first. So graph this thing first. So we've learned how to graph cosine. How is that going to look on here? At 0, it goes through 1. At 90, it goes through 0. At 180, it goes through -1. At 270, through 0. At 360, through 1. So if we graph that graph first, where are our asymptotes going to end up this time? Yes. And then the graph will go upward and downward from those, so that it looks like that. Just follow. Do you see how I used the cosecant graph? Not cosecant. I used the cosine graph to create the secant. Correct? Does that make sense? Okay, so now going to our card, let's get this important information here. Again, I'm just going to throw the graph on there that I just barely created. Maybe I'll do it in blue. So our asymptotes are at pi-half intervals instead of pi intervals. And of course the graph's going to follow the same symmetry as cosine. Right? So what's the symmetry? Fold it at the y-axis. Even. Okay, what's the domain? X cannot equal intervals of pi halves, so yes, k pi halves would be correct. Right? Because you've got pi halves, 3 pi halves. Wait. Oh, it's not quite that easy. You're wrong. My brain is elsewhere, sorry. Yeah. Oh, what's your answer? X cannot equal what? Plus k pi, there you go, good job. I was thinking it before I started writing it down, and then I just went with... Yeah, okay, so now let's analyze why that's true. Why didn't k pi halves work? Because that would be 0 pi halves at 0. And pi halves would be correct. And 2 pi halves at pi. And 3 pi halves would be correct. And 4 pi halves at 2 pi. Do you see how every other one is not going to actually be correct? And so instead of being able to do it that way, we just have to say start at pi halves and then add and subtract pi from there. Because these are all a distance of pi apart from each other. So we're adding and subtracting values of pi, thus k pi. Okay, range. -infinity to -1, 1 to infinity. Okay, period. Two pi. Good. Asymptotes. Notice how the asymptotes in the domain match. Only the domain is what x cannot be, and the asymptotes is the lines where it shows that x cannot be there. So it's the same exact answer, it's just this is not equal, that is equal. Okay, local minimums. Where are the local minimums happening? 0 and 2 pi, so that means it would be values of 2k pi, wouldn't it? Because you'd take your k value, which is just integers, and multiply by 2. So 0, 2 pi, 4 pi, 6 pi, 8 pi. And then your maximum, local maximums, will be where? pi plus 2k pi. So that'll be the odd ones. 1 pi, 3 pi, 5 pi, 7 pi. Correct? Okay. So we're practically out of time. Everything we've learned the last couple days with transformations applies to these. Except if you have, okay, so if you put a number in the parentheses, that moves it left and right. You have a number out front that of the x value within the sine or cosecant or secant, it changes how often it goes up and down, right? It changes that, the period of the graph. You put a number out front and it changes the amplitude of sine and cosine, but is it changing the amplitude for these? No, it would actually change where the minimums and maximums are. Because if the amplitude of the sine graph goes up to 2 and down to -2, your secant and cosecant graphs are now only going to go down to 2 and up to -2 instead. So like I said, if you graph that sine and cosine graph first and then flip it over, your cosecant graph will be correct, or your secant graph. Because it's just a matter of starting where the sine and cosine leave off and going from there. But they don't really have an amplitude because they go to infinity. Does that make sense? So we can't really call it amplitude for secants and cosecants. It's just telling us where our minimums and maximums are. You can also have a vertical shift where the center of the graph moves, right? And again, that can easily be done with a sine or a cosine and then flipping it over for the secant, cosecant. You can also have, did I cover everything? Maybe that was already everything. Phase shifts, we already talked about that. Okay. Lack of time, I'm just going to let you try it and see what you can do with it. But we have a few minutes left. If you have questions on homework you want to go over, or if you want to turn any homework in, we can do that.